Right now, astrobiologists are planning missions to find living ecosystems beneath the frozen crusts of icy moons like Europa. But before anyone launches a multi-million-dollar drill to the orbit of Jupiter, scientists are first working out the bugs on a massive, completely hostile testing ground right here on Earth. Deep underneath the Antarctic ice sheet sits a hidden network of subglacial lakes that have been completely sealed off from the sun for 15 million years. These are immense bodies of liquid water. One of them, Lake Vostok, holds roughly the same volume as Lake Ontario. To figure out how to probe the pitch-black oceans of the solar system, we first have to figure out how to pierce the buried waters of Antarctica. For decades, researchers have been flying planes across the white expanse, shooting ice-penetrating radar straight down to map the bedrock. That radar revealed a highly active ancient world. Hidden under the ice is a trench deeper than the Grand Canyon, the largest volcanic region on the planet, and a towering mountain range. The radar also exposed an active subglacial plumbing system. Fast-moving rivers physically connect these lakes, filling and draining them so rapidly that they lift and drop the entire ice sheet above them by dozens of feet. The constant drainage and filling of these subglacial lakes means we are dealing with an active, interconnected landscape. Reaching the water requires navigating these systems without contaminating the very life we're looking for. To get down to that water, you have to cut through a staggering amount of ice. If you took a chunk out of the thickest part of the continent, it would stand nearly as tall as Mount Kilimanjaro. As a drill cuts downward, the surface snow quickly gives way to firn. Firn is a highly compressed transition layer between snow and ice. It behaves like a frozen, shifting sponge that stretches and snaps to create deadly hidden crevasses. Pushing past the firn, the drill hits clear, solid ice. The heavy pressure squishes the air inside the firn, locking ancient atmosphere into tiny, perfectly preserved bubbles. You can read these layers like tree rings. That thick, dark band is a layer of ash marking a massive global volcanic eruption that happened over 20,000 years ago. Sending a drill bit 2 miles down is a slow, careful descent backward through 15 million years of Earth's climate history. Two distinct thermodynamic forces keep these deep lakes from freezing solid. Geothermal heat constantly radiates up from Earth's core, while the massive ice sheet above acts as an insulating thermal blanket. But the real trick is the pressure. At the bottom of the ice sheet, the pressure is 350 times higher than at sea level. That intense squeezing acts like an antifreeze, significantly lowering the temperature at which water can actually stay fluid. This extreme physics creates an isolated incubator for biology, but it also turns the subglacial lake into a highly dangerous pressure cooker for anyone trying to open it. Piercing that incubator is extremely risky. It is the mechanical equivalent of dropping a mint into a bottle of diet soda, because exposing a highly pressurized system to a sudden release valve can trigger a massive uncontrolled blowout. In the late 90s, a Russian team spent over a decade drilling toward Lake Vostok. To keep their borehole from freezing shut, they pumped it full of a heavy fluid mixture made mostly of kerosene. When they finally melted through the ceiling of the lake, the depressurization forced water to shoot violently up the hole. The pristine lake water mixed completely with the bacteria-filled kerosene, making it impossible to prove if the new microbes they found were truly native to the lake. To bypass this contamination risk, American and British teams later deployed a completely different technology. Instead of chemical fluids, they used superheated water that had been meticulously filtered and sterilized with UV light to melt cleanly through the ice. When they pulled up their clean samples, they found a thriving microscopic ecosystem living deep inside the lake. Engineering that perfectly sterile entry proved definitively that these organisms were a living part of Antarctica, untainted by our equipment. These deep ice organisms survive in absolute darkness. They thrive entirely on chemical and geothermal energy instead of sunlight. That specific biological setup mirrors the exact conditions astrobiologists expect to find deep in the subglacial oceans of the outer solar system. The UV-sterilized hot water drill used to sample these lakes is the direct technological predecessor to the probes NASA is developing to breach the crusts of alien moons without contaminating them. Proving that life can thrive in Earth's most isolated, high-pressure environment transforms the search for alien ecosystems. If a thriving world exists under the ice here, the odds that we are alone in the solar system just got much smaller.